in case of tungsten inert gas welding, usually that is called gas tungsten arc welding, okay, GTAW, and in that cases we have used the heat generated arc generated by electric arc using a non-consumable electrode. Main difference between tungsten inert gas welding and metal inert gas welding, in case of tungsten inert gas welding we use the non-consumable electrode, okay, non-consumable electrode, and the workpiece we have used in that process, okay, and also we provide the current through the electrode and heat will be generated at the end of the tip of the electrode, and due to generation of the heat to the tip it will melt the parent metals, and due to melting of the parent metal then the welding operation has been done. A filler rod may be fit to the arc zone. Sometimes as per our requirement we use the filler rod. Sometimes we use the shielding inert gas, argon, helium we use to in that particular welding operations for creating the shielding gas. Why we use the shielding gas as a argon, helium? To avoid the atmospheric contaminations. Means sometimes the oxygen will react with the molten metal and it will create the oxide that will help to create the rusting on that particular weld surface. That unit consists of particular one power supply, maybe DC or AC. It will be used to produce the arc. Another gas supply unit with pressure gauge and flow meter we have used. Gas supply unit, tungsten inert gas means inert gas unit means that gas supply unit provides the inert gas means argon or helium for creating the shielding to that particular welding zone. A gas regulator fitted to that gas cylinder to control the flow of gases. A gas regulator is used fitted to the gas cylinder to control for flowing of the gas. Another a TIG welding torch, special type. TIG welding torch means electrode will be used to that particular TIG welding operation. A non-consumable tungsten electrode, that is the gel electrode, generally non-consumable electrode, and different shapes also there. A filler rod which supplied the filler metal to the weld pool, means sometimes a filler rod will be used to supply the filler metal to that weld pool, means as per our requirement. Now first one, setup of the TIG welding means here gas supply unit is there, that is the inert gas welding supply unit, and through the torch, and that gas will create some shielding zone to that particular welding operation, that is the torch, okay, that is the torch and that is the tip, and flow regulator will be connected through the flow regulator, and controls will be connected to that particular torch also, okay, and that is the pump, and that is the power supply, that to that power supply the one end will be connected to the workpiece and other end will be connected to the electrode. Setup for TIG welding, here we have seen that is the inert gas. Through that holders or through that particular hoses we have supplied the inert gases, okay, and inert gas comes to that particular welding zone and creates the shielding zone, that is create the shielding zone, creates the shielding zone, and it will help to protect the reaction with molten metal with oxygen, and that is the inert gas shielding. Inert gas creates the shielding zone, and that is the workpiece, okay. And sometimes we have supply we use some water jacket. Why we use the water jacket? Sometimes that electrode will be heated more, so control the temperature to that particular electrode we have used some water jacket, means coolant will be supplied through that point, and that type of water jacket will be added to that particular electrode. Here also we have seen that is the base metal and that is the filler rod. As per our requirement we use the filler rod, okay, and that is the torch means electrode, and tungsten, that is the tungsten electrode, that is the non-consumable tungsten electrode, and through that tungsten electrode we supply the inert gas. That inert gas that creates the shielding zone, that inert gas create the shielding zone, and that is the filler rod, and the molten metal will be created due to arc creation between the metal and that particular electrode. Okay, then after welding, that solidified weld metal will be created. Okay, and then in that way welding operation is going on, and power and shielding gas will be provided through that particular electrode supply unit, and then that is the electrode proctoring cap. Sometimes also that cap will be used for holding the electrode, and that is the ceramic nozzle through which the inert gas will be supplied, and also that ceramic nozzle also holds the tungsten electrode also. Now in that schematic diagram we have seen that first one is the TIG welding equipment setup. In figure 1 I already have shown, and in case of figure B we have seen a specially made TIG welding torch, and the principle of operation of gas tungsten welding it has been shown in figure 7.24c. Now in case of that welding operations, we have seen that high degree of welder skill is required. Okay, and also that is the semi-automatic or fully automatic process. Semi-automatic process, the speed travel and direction of the weld are generally controlled by the operator. Means welding operation, welding direction and speed of the welding, that is controlled by the operator. Means that is the semi-automatic process. And fully automatic process, weld size, welding directions, rate of travel, voltage, stop of the torch, stop of the start of the torch, that fully controlled by the equipment itself. Okay. First, TIG welding torch. TIG welding torch generally made of tungsten. Okay. TIG welding, in case of TIG welding, specially made of electrode holder known as TIG welding torch. Okay, and tungsten electrode will be inserted to that TIG welding torch. Okay, that is the non-consumer. And in that particular welding torch also, through which we supply the inert gas also. Means during welding time it creates the shielding gases to protect the contamination from the atmosphere. The current is less than 200 amperes, air cooled torch will be used in the welding torch. If for current more than 200 amperes, we have used the water cooled torch. Means it helps to control the temperature to that particular welding torch. To produce the good quality using that welding process, the tungsten electrode is chosen according to type of power supply and the thickness of the metal to be welded. On that basis, we have used the tip shape. Generally, tip shape, we are seeing that is the DCSP, means direct current state polarity. In that cases, we have seen that type of tip shape. In case of AC current, we have used that type of tip shape. In case of DCRP, means direct current reverse polarity, in that cases, we have seen that type of tip shape. And in case of AC current, also we have used that type of shape. And also AC current high frequency, in that cases, we have used that type of tip shape. Means here we have seen that the conical shape tip for DCSP, a blunt end conical shape DCRP, and round tip shape used for ACHP. So in that cases we have seen that is the penetration of the TIG welding. In case of penetration DC current state polarity, the penetration shape will be create that type of shape. Means here penetration depth is higher. In case of DCRP, penetration depth is less. Means that type of shape will be generated. In case of ACHP, alternative current high frequency, in that cases the weld face will be created in that type of shape will be created. So penetration depth for alternative current source and direct current source, that will be different. Now what are the process parameters in case of tungsten inert gas welding. First, power source. In case of power source, we use generally direct current and alternating current, and current range in the DC current generally or alternating current, we have used the current rate near about 100 to 500 ampere. Okay, voltage range is 40 to 60 volt, and another temperature type generally 2700 degrees centigrade to 3600 degrees centigrade temperature will be created during arc generation between metal plate and electrode. And another is electrode type. Electrode type generally non-conjugable tungsten electrode we have used. Electrode diameter varies from 0.35 to 0.75 millimeter. Electrode tips may be conical or may be blunt edge, conical or may be round shape. Source of power source for tungsten gas welding, generally it will be DC current source or maybe AC current source. The choice particular which consider for the following: DCRP in case of direct current reverse polarity, which metals we have used for welding purpose. For thin sheets of aluminium and magnesium alloy, in that cases we have used the DCRP, okay, direct current reverse polarity. In case of direct current straight polarity, we have used high melting point materials like alloy steel, stainless steel, heat resisting alloy, copper alloy, nickel based alloy, titanium. That type of metals we have used in case of direct current straight polarity. In case of alternative current, generally we use the normal sheets of aluminium and magnesium we have used for using AC current for welding. That tungsten inert gas welding we have used for welding of non-ferrous metal in all positions. We have done the welding using that process in any type of non-ferrous materials also. And some applications and uses are, that is the metals alloy having various thickness types of joint can be welded using that welding process. It is easily suitable. Another also welding alloy steel, stainless steel, heat resistance alloy, refractory metals, aluminium, magnesium alloy, titanium alloy, copper, nickel based alloy, steel coated, all with low melting points. Easily we have done the welding using that process. This process also recommended very thin sheets near about 0.125 millimeter. Up to that thickness we have done easily welding using that welding operation. And also this welding is very smooth, clean and sound weld. Okay. This process also used in for welding purpose, fabrication of missile, aircrafts, rockets and also submarines. In that cases also we use that welding process for welding purpose. Also we used for welding to the particular commercially pure titanium, that is very advanced material. What are the advantages of TIG welding? First one, any type of welding or any type of metals we have done using that welding process. Means any type of power supply, AC, DCSP and DCRP, using that power supply we have done the welding easily. Another smooth, clean and sound weld we have got using that welding process also. And another, the welding joint must be stronger, more ductile and corrosive resistance. Okay, that welding very good welding process. And also that welding is used for ferrous and non-ferrous materials, and also it will be easily joined the dissimilar metals also. And what are the disadvantages of tungsten inert gas welding? Before welding, proper cleaning of the workpiece is required. Means no any type of impurities or any type of contaminants does not stick or does not attach to that particular welding zone. Means proper cleaning is required before welding. Another, cost of the inert gas, that is also very high, but it is required for shielding purpose. Another, other side of the joint do not protected in this method. Means where we do the welding to particular means welding zone, particular welding zone, it will create the shielding gases, but other side it does not create any shielding gases. In other side maybe react with oxygen, maybe create some oxides also. Now metal inert gas welding, and in that welding operations we have used the conjugal electrode. Main difference between tungsten inert gas welding and metal inert gas welding, in metal inert gas welding we use the conjugal electrode, in case of tungsten inert gas welding we use the non-conjugal electrode. And in that welding operation also, and in the metal inert gas welding generally also use the shield gas shielding thing in case of metal inert gas welding, because it also helps to protect the reaction with oxygen during welding time. And also metal inert gas welding, the electrode holder, conjugal electrode holder creates the heat between the metal and electrode holder, electrode torch, and conjugal electrode wire and the metal to be welded. Metal transferred through the protected arc column of the inert gas. Okay, generally here we use the wire coated electrode. Wire of copper coated mild steel is fed continuously from the wire reel, means it will act as a conjugal electrode. Another current near about 100 to 400 ampere we have used, that will be depending upon the diameter of the wire. Based on that we decide the current range. Another Ca2 principally used apart from the argon helium mixtures, means as a shielding gases we use the argon helium mixture. The welding machines may be generally DC constant current, constant voltage machines we have used MIG welding operation. What are the advantages and disadvantages in case of MIG welding? First one, no flux is required. No flux, no granular flux we have used. Fast welding and deposition rates also high. That's why it is very highly productive. Increased corrosion resistance, means here we use shielding gases but no flux will be used. That's why sometimes molten metal will be created. During creation of the molten metal, maybe it will reacted with the oxygens, and due to reaction with oxygen it will create the oxides, means it leads to rusting. Easily automated welding, means that welding operations may be automated welding operations, suitable for all metals including aluminum, stainless steel, means all type of materials we can weld it using that MIG welding operations. And least expensive and highly economic, that process is highly productive already I have told. That's why means higher deposition rate and fast welding. Due to that thing, that is very highly productive process. And the arc is less stable. What are the disadvantage? Means created arc between the metal and electrode, that is the very less stable and generates more spatter, means during welding time some particles will be accumulated on that particular metal surface, means that is the one of the most disadvantage in that process. Limited to short circuit mode of metal transfer, sometimes short circuit mode generally limited. Another relatively high heat and light generations, means when the arc will be created during welding time, the heat is very high, but light generation, that sometimes it will create it very high and it will sometimes create light heat. Due to that thing, sometimes welding quality, sometimes it will deteriorate. Equipment is quite complex in that cases, because here we have used the conjugal electrode holder. Sometimes means the holding of that conjugal electrode, sometimes it is critical, okay, and not suitable for base metal contaminations, means sometimes we does not remove the base metal contamination. Due to that thing, the weld quality sometimes also deteriorates. What are the tools and equipments used in case of MIG welding? First one, power source. Power source generally DC constant voltage transformer we have used. Another, wire feeder. wire feeder is used to required to feed the electrode wire continuously and smoothly during welding time. Then conduct and hoses. That conduit facilitates feeding of the wire. That conduits help to feeding the wires to the torch continuously and smoothly. That is the conduit and hoses. Another is welding gun. It transfers the welding current to the wire and provides the gas shielding during welding time. Means welding gun transfer the welding. That welding gun helps to current to that particular conjugal electrode, and also it will help to supply the inert gas during welding time also. Here we have seen that is the gas cylinder. Actually that gas cylinder stores the shielding gases like argon, carbon dioxide, that type of gases stored to that particular cylinder. Okay, that is the cylinder valve and that is the flow regulator, and using that regulator we control the flow of the gases, inert gases, and that is the gas hose, and gas hose connected to the electrode and through which the gas will be goes to the welding zone. Another safety equipment, that are the number of safety equipment, that is the safety goggles, safety helmets we have used during welding time, safety ear plug, means sometimes very sound will created during welding time, that's why we use the safety ear plug. And also reflective jackets, means ultraviolet radiations also created during welding time, that's why we use that type of radiative jackets. And also use some safety hand gloves, means arc will be generated, globules will be generated, maybe when it will come to the human body it will sometimes may create some health hazards may be created, that's why we use some safety hand gloves also. First aid box during welding time, sometimes maybe some health hazards will be created, that's why first aid box is needed. And also sometimes we use safety ring also. That are the some particular safety equipments we have used during welding time. And some defects, what are the defects has been generated? Sometimes undercut means the metal will be, means welding, some welding zone will be created just below the metal surface, means that happens when the weld reduces the cross sectional area thickness of the base metal, means that type of things will be created, the undercut. Lack of fusion, some part of the welding zone does not fuse properly, means that is the lack of fusion, means that part does not fuse properly. Due to lack of fusions, that zone does not weld properly, means that is the lack of fusion. Another thing, inclusion, sometimes some contaminants, some impurities will be stored to that particular welding zone, and that thing deteriorates the weld quality to that particular welding zone. And end of this lecture, the students have learned about the basic principle of the arc welding, voltage current characteristics, curves of the power source, problems on voltage characteristics, duty cycles, manual metal arc welding, submerged arc welding, tungsten inert gas welding, and metal inert gas welding. They have got some idea about that welding process. That is the TIG welding setup, and that is the power supply unit, that is the gas cylinder from which the shielding gases will be supplied, that is the gas valve, power supply unit, that is the coolant system, and regulator is there to control the flow of the shielding gases, shielding gas cylinder, and that is the remote control through which we control the welding operations, and that is the work clamp will be connected to that particular workpiece, that is the welding torch. One pressure gauge will be used to measure the flow of the shielding gas pressure, and one pressure gauge will be used to measure the pressure inside the cylinder. Here shielding gas will be emerge out through that particular welding torch, and here also the shielding gases zone will be created, and it will be help to protect the weld zone from the formation of the any oxides, and that is the conjugal electrode, and that is the created arc, and in that way the welding operation is going on. And that welding is the defect free joint, means no contaminants will be created there, means no oxide will be created in that particular welding zone. Now MIG welding setup. That is the power unit, that is a shielding gas unit, and here we use the, that is a shielding gas control unit, and electrode holder we use the consumable electrode here. There is a metal plate connected to the power supply, and that is the electrode torch, and electrode torch here, electrode is the consumable electrode, means additionally we have not hold the any consumable electrode. That is the consumable electrodes. Shielding gas, and in that way the welding operation is continuing. It also does not create any oxides during welding zone also.